Hello, this is page 231 of the Incredibles book, and we are working on a definite integral. At the top of the page, there is a definite integral problem. However, it says define the integral using the limit definition, and we are skipping that topic. All right, so we start with here. So the definite integral, a way to interpret the definite integral is thinking it of as the area, right? Area between a function and the x-axis between two vertical lines. So that is how we can think of a definite integral. You might see over here, say, well, there's no vertical lines here. There is a cutoff point, so you don't have to have vertical lines. I am being cut off by a function on the left side, function on the right side, and the x-axis on the bottom. So it's always going to be x-axis. It doesn't have to be on the bottom, it could be on top. But the idea is you can think of the definite integral as an area. So here, we have some function f, right? This will be the function f here, the horizontal line here. Okay, that's the function f. And a is the lower endpoint, which would be 0. And b is the higher endpoint, which is 5. And the area of this would be, just find the area like you would like a normal rectangle. So it's 5 by 4, so it's 20. So that's the definite integral of this function from 0 to 5. All right, moving on to the next one. So this one is confusing because of the floating number 16 here. That's actually the answer to the question, I believe. Okay, well, let's look at it. So we say this upside down, or this triangle, is going to be our function, and we're going from -4 to +4. Okay, and just a triangle, so this length is 8, the height is 4. 8 times 4 is 32, divided by 2 is 16. So that's what we were saying, that there's a area floating there. All right, and then here, so here they're asking you to do this by geometric formulas. All right, so there is a way to do this by integration, regular calculus techniques, but we're doing geometry techniques here. This is useful when the graph is provided. So here, where they ask you to write the graph, it's probably not going to happen very often, but we're going to do that here. So we have a graph of y equals 2x plus 5. So we have a y-intercept of 5 and a slope of 2. All right, going from 0 to -2. So we just need this part right here. There's the -2. And that's the area we're looking for. All right, to do that, that's a trapezoid, right? The two parallel sides are here and here. And the height will be this way. So this is trapezoid on its side. So that's going to be equal to, so the area of a trapezoid is 1/2 the height. The height here is 2 times the sum of the bases. The left base is 1. The right base is 5. So that's going to equal 6. That's it. All right, square root of 9 minus x squared is the equation of a semicircle with a radius of 3. All right, if you're concerned with being able to recognize that on a test, okay, so the equation of a circle looks like this, or semicircle looks like this: r squared minus x squared, where r is the radius. Okay, so this is square root of 9, so that's how I know the radius is 3. All right, so this is my semicircle. All right, so it's a semicircle with a radius 3. So it is pi r squared, the radius is 3, divided by 2. So it's 9/4 pi, or 9 pi over 4. All right, here we go. C, we have an absolute value of x. So absolute value of x, so I'm going to sketch it several times here. Absolute value of x Let's try this again. Absolute value of x looks like this, right? And when they put a negative sign in front of it, it looks like this. So not this part up here, but the downward version. And then when you add 1, which is essentially what that's doing, it moves it up by 1. Okay, so then the graph looks like this. And that's just a triangle with base of 2, height of 1. So it's 1/2 base times height, base of 2, height of 1. So that's equal to 1. That's it. Moving on to the next page. All right, so I'm not sure if we did this in class, but I will do this here. We're going to, let me zoom out a little bit if I can. I don't know if I can. I cannot. All right, so here, we got a definite interval. And this is a semicircle, radius 2. And when you're given a problem like this, it's probably, no, we did do this in class. All right. When we're given a problem like this, it's easier to go ahead and just fill out the information in pieces, and you want to do it in vertical breaks. You don't want to do horizontal breaks. Now, this one doesn't lend itself to horizontal breaks, so that's okay. This is a semicircle with radius 2. I can tell because here will be the center. The radius is 2 all the way around. All right, so it'll be pi r squared over 2. So we're doing pi 2 squared over 2, so it's just 2 pi. All right, and then we're going to do this little piece here, which will be 2 times 1 divided by 2. It's a triangle. The base is 2, the height is 1. So it's 1/2 2 times 1, which is just 1. And we have these 3 rectangles here, so it's 3. And this piece is a half. And here is negative 1, 2. So it's negative 2. It's negative because it's below the x-axis. So you can think of integration as signed area, where area has a positive or negative sign. Now let's look at this. A, 6 to negative 6 to 6. So we just add all these up. So it'll be 2 pi plus 1 plus 3 plus 1/2 and minus 2. All right, so all I did was add those pieces together. Okay, add those pieces together, and let's clean that up some. So it's 2 pi, 4 minus 2 is 2, 2.5 is 5/2. Yes, I prefer improper fractions to mixed numbers. Okay, now we're going from 2 to 6. So 2 is here, and 6 is here. So we have 1.5, and this is 2. So we're going to add 1. Okay, this is negative 2, but it says absolute value, and B says absolute value. So we're going to look at an absolute value that is 2. So it's 2, 3, 3.5. 3.5, or 7/2. And then here, this, whenever you have x plus 2 in here, just rewrite this by adding 2 to the limits. So that's negative 2 plus 2 is 0. 1 plus 2 is 3. And get rid of that plus 2. So now you're just looking at it from 0 to 3. So 0 to 3 is 3. Right? Here's 0. Here's 3. 1, 2, 3. Now we're looking at D. So here, all you're going to do is move everything up by 2. You can think of this as 0 to 3 of f of x dx plus 0 to 3 of 2 dx. So if we have a height of 2, it's simple. So this part by itself is 2 times the width of that. The width of that is 3, because 3 minus 0 is 3. So that's just going to be 6, 2 times 3. And then 0 to 3 f of x, that's this piece here, 0 to 3. We've done that a minute ago. So it's 3. So it's 3 plus 6, which makes 9. All right, 3 is this piece, 6 is that piece. All right. Okay, 0 to negative, or negative 4 to 0. And we're doing the opposite of f of x. So negative 4 to 0, negative 4 to 0. So negative 4 is here, all the way up to here. And we're taking the opposite of it. So we're just going to change signs. So negative 4. So this was 2 pi. The whole thing was 2 pi. So half of that is pi. So it's pi. And this piece is 1 plus 1, but we want the opposite of it because of this negative sign on the f of x. So that's negative. All right, moving on to f. We're going 6 to negative 6, except we want the opposite direction. We want the opposite to go negative 6 to 6. And we want to flip it around, which really doesn't change anything, does it? I guess it does. All right, so remember what we did up here? When we have an x plus 2 in here, we just added 2 to this. So when we have a negative x in here, we basically change the sign. So it's 6 to negative 6 of f of x dx. So if you recall the properties of integrals, when you do this, you change the sign. You change the sign. So 6 to negative 6 is going to be the opposite of negative 6 to 6. So we just change that sign. So it's negative 2 pi minus 5 halves. All right. Moving on. G. Now we're taking the absolute value of x from negative 3 to 6. So this means it's the same thing as negative, no, not negative 3 to 0. 3 to 0 of f of x dx plus 0 to 6 of f of x dx. Right? We took the absolute value of whatever you're putting in. So the value we're putting in is negative 3 to 0. So we want absolute value of that though. So 3 to 0. 3 to 0. So we're going backwards. 3 to 0, we're going backwards. So that's a negative 3 here. Plus, and then 0 to 6. 0 to 6, we're going from here, 0 to 6. So it's 3.5 minus 2, which would be 1.5. So we add 1.5, or we'll just add 1.5. So negative 3 plus 1.5 is negative 1.5, or negative 3 halves. I guess this was a little easier with the improper fraction. I mean the mixed numbers. You can leave it mixed numbers. All right. Using the properties of integrals, when the top and bottom limits are the same, that value is 0. All right, here we got 3 to negative 6. We're moving on to I already. Normally we go from negative 6 to positive 3, but now we're doing it backwards. We're doing it backwards, right? We're doing 3 to negative 6 instead. So if it's backwards, you change the sign. So what is the sign? What is it from negative 6 to positive 3? It's 2 pi plus 4. So that means we're changing the sign. So it was 2 pi plus 4, but because we're going backwards, we're going to change the sign to the opposite of that, right? From, if it were this, if it were negative 6 to 3 of f of x, it would be, sorry about that. If it were negative 6 to 3, it's 2 pi plus 4. But because it's backwards, we just change the sign. And that's page 233. I don't know if we're going to do another page. I think that's it. All right. Sorry if that was confusing. Okay, good luck.